level hot and running in park or neutral. For modern vehicles without dipsticks, service information is essential as procedures vary, often needing special tools or a scan tool. A simple pan drop and filter change won't replace all the fluid, especially in the torque converter. Newer flush machines address this, but don't replace the filter.
Now, let's shift to off-vehicle transmission repair, starting with removal and installation. Are there significant differences between RWD and FWD vehicles?
Yes, significant differences. RWD removal is generally simpler, one cross member and one drive shaft. FWD transmissions can be complex due to limited space, often requiring removal of large assemblies like the engine cradle or suspension components. Regardless of the drivetrain, a key step is ensuring the converter comes out with the transmission to prevent damage to the input shaft or fluid pump.
Once the transmission is out, what specific components require close inspection before reinstallation?
The torque converter flex or drive plate needs inspection for cracks, which can cause knocking, and for elongated mounting holes indicating loose bolts. The converter pilot and crankshaft pilot bore must be checked for wear, which causes vibration and necessitates converter replacement. It's also wise to measure the converter's seated depth before removal to ensure proper installation later. The pump drive hub and front pump seal area also need inspection for wear or scoring.
And for installation, what's crucial for the torque converter?
It must be fully seated into the transmission, ensuring the drive lugs properly engage the pump. If the converter isn't deep enough after installation, it's not correctly aligned. A test fit into the crankshaft pilot bore helps confirm adequate clearance for expansion and contraction during operation.
The transmission fluid cooler can also cause problems, even after a transmission replacement, if not properly addressed.
Yes, a faulty cooler can quickly damage a new transmission. Inspection for leaks, airflow obstructions, and bent fins is critical. More importantly, if internal components failed, debris gets trapped in the cooler. If this isn't flushed out thoroughly with an approved solvent, often via backflushing, it can enter and damage the new unit. Pressure drop and flow tests can identify a clogged cooler.
Routing and installing brackets, wiring, and fuel lines seems like a detail, but it's important for reliability.
It's vital. Due to tight spaces, components can be damaged or improperly reinstalled. All heat shields and brackets must be replaced. Harnesses and fuel lines must be kept away from exhaust pipes and moving parts to prevent damage and comebacks. The rule of thumb is to install everything as it was from the factory.
With electronically controlled transmissions, what happens when a new unit is installed or the battery is disconnected regarding module coding and programming?
New units have different characteristics, so the control module's learned values must be erased and relearned for proper shift patterns and feel, usually done with a scan tool. If the battery is disconnected, these values are lost, reverting to factory defaults, which may not provide optimal shifting for a worn transmission. The vehicle may eventually relearn through drive cycles, but a specific manufacturer drive cycle is often recommended.
Moving to the actual disassembly and assembly of the transmission, cleanliness is paramount here, I imagine?
Absolutely. Before disassembly, the exterior must be meticulously cleaned to prevent dirt from entering. During internal cleaning, avoid solvents that can decompose friction composites. Use compressed air to dry components, never rags, as lint can destroy a rebuilt transmission. Before removing the torque converter, measuring its setback in the bell housing is good practice for later reassembly. Once removed, inspect the converter for damage, especially the hub for grooves from hardened seals and the pump drive hub for wear.
And for the actual internal components, like the fluid pump?
Inspect the pump bore for scoring and ensure the front pump bushing has correct clearance to prevent gears from running off center. Check the stator support for looseness and inspect splines and bushings for wear. Pump cavitation is a concern, often caused by excessive pump pocket or gear face clearance, which allows air to be drawn in, leading to momentary power loss. Technicians must accurately measure these clearances using feeler gauges and straight edges. Proper alignment of pump halves and checking seal rings are also critical.
You also mentioned bearing preload, backlash, and end play. These are intricate adjustments, aren't they?
They are fundamental. Backlash is clearance between gears in mesh. Too much or too little causes wear or failure. End play is axial looseness of a bearing measured unloaded, usually with a dial indicator. Preload is an adjustment to put a load on an assembly at ambient temperature to compensate for heat expansion. All require precise measurements with tools like dial indicators, shims, and torque wrenches. Incorrect adjustments cause overheating, rapid wear, or failure.
Thrust washers and bearings also seem to fall into this category of critical inspection.
Yes, thrust washers support axial loads and prevent rubbing. They come in various thicknesses to adjust shaft end play. Both flat washers and bearings need inspection for scoring, flaking, or wear-through. Plastic thrust washers are checked by measuring thickness. All damaged components must be replaced. Bearings should be checked for roughness, cracks, pitting, or signs of overheating, using techniques like slowly rotating races or using a vise for ball bearing. Shafts must be examined for wear where they ride in bushings or seals, and for spline damage. Scoring indicates lack of lubrication and requires replacement. Internal fluid passages must be clear. Blockages starve bushings. Technicians must verify check balls are securely in place, as a missing ball causes pressure loss. Small scratches can be polished, but grooves or scores require replacement.
The fluid delivery circuit includes seal rings, feed pipes, orifices, and check valves. What are the common issues found here?
Leaks can stem from worn gaskets or cracked housings, not just seals. For seals, inspect the lip for wear, warping, cuts, or embedded particles. A hardened lip indicates heat damage. Ensure spring-loaded seals have springs seated. Check the seal bore for nicks or gouges. All check balls must be clean and function correctly.
Bushing inspection and replacement seems pretty straightforward, but are there nuances?
It's critical to note the depth and fluid groove direction before removal. Lubricating holes in bushings, especially in planetary gearing, must align correctly to prevent blocking fluid delivery. Wear is indicated by noticeable lateral shaft movement. Clearance is measured with a wire-type feeler gauge. For replacement, proper bushing drivers and an arbor press are preferred to prevent damage or swelling.
Planetary gear assemblies are the heart of many transmissions. What should technicians look for during inspection?
Inspect all planetary gear teeth for chips or stripped areas and splines for mutilation. Blackened gears or pinion shafts indicate severe overloading. Excessive backlash means wear. Each gear should be rolled on its shaft to feel for needle-bearing looseness or roughness. Pinion gear end play is checked with a feeler gauge. Thrust surfaces must be inspected. Sun gears need similar scrutiny, checking for chipped teeth, cracks, or worn internal bushings.
And the transmission case itself, beyond cleaning, what specific areas need attention?
After cleaning, check all bushings, fluid passages, bolt threads, clutch plate splines, and the governor bore. Passages can be checked for restrictions and leaks with compressed air. Since modern cases are aluminum, they deform easily. Critical bores like clutch, pump, servo, and accumulator must be smooth to avoid scratching seals or causing piston hang-ups. Imperfections in steel or cast iron parts can be polished, but never use sandpaper. Porosity in the case can cause cross-tracking of fluid circuits, leading to bind-ups. All check balls and screens must be in place and clear. Restricted vents mimic a weak pump and should be checked with flow tests or by blowing air through them.
That's a remarkably thorough overview of the Ase A2 certification requirements. It truly underscores the blend of mechanical and electronic expertise needed for modern automatic transmissions. Thank you for walking us through these complex diagnostic and repair processes.
You're welcome. It's a field that constantly evolves, demanding continuous learning and meticulous attention to detail.
If you found this discussion helpful, consider sharing this episode with a fellow automotive enthusiast or technician.